everyone. Welcome to our webinar today. My name is Jill Hurston. I'm with SynerZip. Thank you for taking the time out of your days today to join us for our webinar. I'd like to introduce our moderator today is Hemant Elhans. He is the CEO and co-founder of SynerZip. Hemant, over to you.
Great. Thank you, Jill. And welcome all of you. I'm delighted to have this topic of forecasting using data or agile forecasting, planning, and metrics, and have Troy Magennis, who is a real thought leader on this topic, share with us how to forecast capacity or delivery dates for software, especially software projects, and do that in a very empirical, data-driven way using his team's historical data. And this allows planning to take into account the uncertainty which is inherent in software development and manage risks. So very relevant topic for our clients and our ecosystem, people who do software projects and often find themselves challenged on how to reliably predict delivery dates and estimates for software projects. So with that, let me turn it over to you, Troy, to start the webinar. Over to you, Troy.
Okay, thank you. Welcome to Forecasting Using Data, and today we're going to talk about using data and how to become predictive when things are unpredictable. So my passion is around data visualization and helping people see and use data, and one area where I see it being used poorly is when we start using data to punish people and people get fearful of data capture and they start fudging the numbers. So a lot of the work I'm trying to do is trying to help people to use data in a better way and in context so that it's reliably being able to be used as a predictor of the future. And one of the other areas I see our industry is pretty poor at is we actually overthink our world is predictable, and we sometimes sacrifice value in trying to make it predictable. So a lot of the tools I'm talking about today are trying to help you embrace unpredictability to maximize the value of what you're delivering. And I want to see us make better decisions in that area. So everything today you're going to see, nothing is sold. I'm going to show and discuss a couple of spreadsheets I produced that are starting points for your journey on forecasting, not ending points. These links are shown here. They'll be in the email that you get tomorrow, and they'll also be at the end of the deck. So I just want you to realize that everything I'm going to talk about is immediately actionable for you today and tomorrow, and nothing's for sale here. So first of all, I want to actually recalibrate your brains into understanding what a forecast is. Now, a forecast is a guess about how the future is going to play out. And its utility is in detecting earlier that reality isn't matching what we expected. And I see a lot of people thinking that a forecast is a commitment. It's not. It's a device that helps us understand whether we understand our delivery system well enough that we can make and align reality with the forecast. So it's not about being right at the end of the project. It's about being right throughout the project and always tracking reality and using the forecast to sort of say, something weird's going on here. Maybe everyone having to work from home is having an impact on our plans, and know that earlier, respond with a much lighter hand, and eventually reach an agreed delivery point with as much value as we can. So forecasting isn't just about testing when will it be done. It's about knowing earlier, will it be done when we think it should have been or could have been. But reality is always right. What we're looking for is the reasons our forecast is wrong, because it shows a gap in our knowledge as to understanding the complexity of what we're trying to deliver. So this is the way you forecast. You build a model the best you can with the best understanding that you have of the system that you're delivering. Then you forecast using that model, and you constantly compare reality, and you find out where the gap is. And then you correct that gap, model again, forecast, and compete and just go around the cycle as fast as you can. What you're really trying to do is say that you have an understanding of the major factors that are at play in your delivery system and that you've got them under control. So think of forecasting as a way of detecting earlier that there's something that you missed in your planning. And that means that you know earlier and you can do a much lighter touch to course correct. And, it's not about everyone says my forecast right. No, your forecast isn't right. It's about understanding why it's wrong. That's the value in it. So, all models are wrong, some are useful is the quote from statisticians all over the place. But it's just the fact of life that we have to get used to. Don't set a forecast and commit to it. Set a forecast and then track towards it, making decisions along the way. So how do we do that? Part of what we're understanding or we need to understand is that we have a system which is capturing data. And this is one of the spreadsheets that I have, which just take a cumulative flow diagram, fit a couple of lines on the arrival rate and departure rate of work, and just roughly understand whether they're parallel. Are we keeping up with the incoming demand? But the point I want to make with this chart is that we should only believe the forward projection of this chart if it reliably predicted something that happened in the past. So we need to use our models to forecast something that we know happened to actually understand whether they're going to be useful or should be useful in forecasting the future. And I see people doing a lot of forecasting where they're just starting from the point of today and forecasting forward without understanding if their model actually fitted the recent history at all. And I want to cover this pretty sort of rapidly and early on in this talk. How do you do that? Well, assuming that it's now July, it's not, but assuming it is, so where it's just starting the first green circle in this timeline, you've got 6 months of team history. Maybe you don't. It doesn't really matter. What I want you to do is halve the data that you have in historical data. So if you have 6 months, split it into 2 groups of 3 months. Then I want you to model using the first 3 months of the year, the January, February, March. And then I want you to forecast using that data to forecast something that you know actually happened in the truth. And I want you to see if your model was predictive in this aspect of it. If it wasn't, don't go forecasting the future. Go and find out why January, February, March's data wasn't a reliable predictor of April, May, and June, and do something about it. And at the moment, this is exactly what I want to talk about, is that if we started using the historical data from January and February, March to forecast what's going to happen in April, May, and June at the moment with the COVID-19 virus around and everyone working from home and having to look after kids who aren't able to go to school, your future forecast will be wrong. So we actually do have to really constantly consider whether the historical data is still useful at all. And what I see is people keeping data that they should throw away rather than actually, not having enough data and those errors. So only once you're able to get a known truth to forecast using a model should you think about going off and giving a date further into the future using that data. So this is the key point there. Is forecasting is about knowing and detecting earlier that you're wrong and understanding why. And until you can forecast something that you know happened using a model, or the simplest model that you can, stick clear of forecasting the future. So with that, Hamid, just heading over, are there any questions at the moment on this section?
Yeah, Troy, no questions so far right now. Maybe one question I would inject is maybe you can shed some light on aggregate level of forecasting for a project versus a granular forecast of when a certain feature will be done. Is more of what you're saying forecasting pertain to the aggregate level when the entire project will be done, or is there a way for teams to be able to use this approach to be able to predict specific features?
Great question. The level that you forecast at can vary. Now, the shorter the time duration you're forecasting, normally the more reliable the outcome as you go further out. If you try to forecast what you're going to deliver in 2 years' time, a lot can change between now and then. So, you know, traditionally, I try and limit my forecasting spreadsheets to go out no more than a year. Some types of forecasting errors compound. So, you know, if you're doing feature by feature and the first feature is late, of course, that's going to affect all features after that. So I tend to try and forecast feature by feature. That way I can recalibrate the start date for the future features on some known truth, not just some speculation. So that's the way I would do it. And I show later in this talk, you'll see how to do both, and then I give you the benefits of breaking it down into features later in the talk.
Great, sounds good. Thank you.
Okay, no problem. I'll keep going on. Next section here. So, first question you get asked: forecast a future value, some number, something numeric, and this is an area of time series forecasting. It might be the number of help desk tickets we're expecting to get. It might be the number of support requests for ramping up new PC, new laptop configurations. So it's a value that we know has some historical values, and we're trying to forecast what it's going to be in the future. So an example might be roughly what will the throughput be for our 100 teams in 6 months' time. And often we look at a cumulative view of throughput delivered by teams, and you can see that this sort of growth looks like it's a nice predictable process. That great, we can be pretty good forecasting out in what our total throughput's going to be in 6 months' time, because this is nice and stable. But the problem is, this is the exact same data. The exact same data, and rather being plotted cumulatively over time, which is often what we use for forecasting, you can see that it doesn't look very predictable anymore. It's got these huge troughs. It's got these huge ragged edges. And, you know, even if we wanted to pick a trend line to forecast what a future value will be,
I don't know. I think I'm not hearing.
Yeah, I think we have lost audio. Troy, can you hear us?
I'm back.
Gosh, okay.
Sorry about that.
Oh, okay.
I'm back. Can you hear me?
Yeah, we can hear you now. Try.
Good. So as you can see in this one, you have no idea which bit of data you should use to forecast. And I mean, what happened in these locations? Well, you know, it is around Christmas time, and it looks like it should be probably people taking vacation. But I will tell you that only 5% of people took vacation at this time. This whole drop of 100 teams dropping to almost zero throughput for a month was because 4% of people were on vacation because of a HR policy. If you didn't use your annual leave by the end of the year, you lost your annual leave. Now, why 4%? Because of dependencies between teams. If those sort of people are away, all of a sudden you impact the flow through the entire system, and you put some people into massively high utilization, and log jamming the system, and nothing makes it through. And it's not like you had a huge rebound in January and February where you had this huge pent-up amount of half-done work completed. You lost that month, and it was a HR policy. So when I hear people arguing on Twitter whether a 1, 3, or 5-point story matters to a forecast, I think of these system-level events and sort of saying, you're a rookie. There's nothing you can do in estimating poorly which will make up for like a bad systemic policy as this HR policy was. So the long and the short of it is, data, when we try and do a burn-up chart anything cumulative type of chart makes data look very stable. And long term, that's okay for forecasting. Short term, if you're trying to do a forecast of a project that was scheduled to start in November and December and it went through December and January, you will be way wrong because you haven't applied your system context as to what's going on.
So Troy, let's take one question since it's pertinent to the chart you were just showing. So, and pertinent to the times we are in this week and so on. So the question is, given the recent and this week's work from home situation, the data that teams have right now for forecasting pertains to their working from office. Any guideline you would provide, again, keeping this approach in mind, that how would they correct their forecast to account for the fact that now teams are working from home?
What a great question, and I have a slide particularly on giving you some techniques to do that coming up in probably about 10 minutes. So sounds good. Everyone is facing that problem at the moment, that the historical data you have doesn't feel relevant anymore, and you're right, it isn't. So we need to be able to take into account these situations. So I will a couple of my examples here, and then when we get to forecasting, I'll particularly show you some techniques that you could apply using any spreadsheets, but especially my spreadsheet right now, and you have to be considering the global impact at the moment. So I will absolutely answer that question. I'm just going to leave it 10 minutes.
Sounds good. We'll wait. Yeah.
So this is exactly, and it fits into this category, any forecast of a number going forward has a trend line, a line that it's average, it's growing at a certain rate. It has some pattern to it, often that the days of the week matter. So think about getting password resets. You get more of those on Mondays than you do on Fridays because you've had Saturday and Sunday for a person's password to expire, so there's more opportunity. We need to sometimes we need to consider that at different times of the year we're going to have a decline. I just showed you one in that previous chart that December and January are dead months. Sometimes there's a vacation period. In Europe it's August. No one is working during August. In Australia it's December and January. Everyone's at the beach getting skin cancer. There are always these seasonality and the patterns, and sometimes they're based on the weather and sometimes they're based on the process that we use to develop. And then there's this noise, there's these special cause factors, and we're in the midst of, I make the noise look like it's a very small refining point here to this forecast, but at the moment it's going to be the majority factor of our future forecast is going to be how companies are learning and handling working from home versus working in person. So when we're forecasting a future value, we're looking at these three aspects of factors, and we're trying to work out which one we're most exposed to. And long term, the trend is normally the best predictor. Medium term, you've got the trend and the seasonality because you want to take the trend line, and you also want to apply whether there's a special pattern, or whether it's a Monday, or whether we're on global lockdown. But if it's immediate term, it's in the next couple of weeks, and you're in a smaller time frame, you want to start worrying about special concerns, context that isn't captured in the historical data, people taking vacations and so forth. So there isn't a best predictor. You actually have to keep a human in the loop. You actually have to make sure you understand which one of these three factors are important in your context. So here we go. Here's a bit of a trial run and a test to see how good you are at understanding what might impact demand. Ice cream sales. What's going to impact ice cream sales? Have a think about the factors that might cause ice cream sales to be high or low. Is it the trend? Is it the seasonality? Or is it special cause? Well, setting aside the special cause of relationship breakups, it's normally going to be the temperature. The outside temperature actually correlates and is the determining factor of what your ice cream sales are going to be. And rather than using sort of temperatures and having to understand what the temperature is exactly, we tend to use season. Is it winter or summer? We're likely to sell more ice cream during summer. Now, I don't think that many of you manufacture and sell ice cream, but we need to think about what are the factors in our processes which are similar to this, things that change the demand. And often it's when we have our sprint planning meetings, whether we're actually just put out a new service pack or a new release, that might impact the amount of incoming help desk calls that we get. So there's always going to be a pattern of seasonality that you've got to consider, but you're going to have to think about them. Here's some of mine. I used to be responsible for some of lastminute.com and Travelocity in doing sales of hotels and airline tickets. And every time we ran a TV advertisement, it had massive transitions in the amount of traffic that we saw on our website. That's why we ran the TV advertisement. And especially in lastminute.com, they used to run these campaigns, when it's gone, it's gone. Well, we would do those at 7 p.m. in the evening, where traffic would normally be sort of fairly low, and then all of a sudden we'd get up into the hundreds of thousands of hits a minute, and we would have to cope with that transition. Now, if we weren't prepared for that, if we hadn't understood that it's quite common that we run campaigns at 7 p.m. at night, we wouldn't have had the capacity to actually handle that. So that's sort of one example. Another one, this is another special cause. Iceland volcanic eruptions massively changed airline travel, massively changed the amount of hotels and where those hotels were actually booked overnight without any sort of forewarning. So that is a special cause that was unpredictable. And the TV advertisements and the Amazing Race sort of sponsorship were special causes that we could predict. So don't go belting your teams up about not being good at forecasting the events on the right-hand side, the Iceland volcanoes, but look very deeply at your process and try and understand what those special causes are on the left, which are predictable. So how do you do this? One of the spreadsheets I'm going to show you, all it does is, if this is help desk tickets, or if it's bug reports, or if it's number of releases, start tracking the date that those items actually occurred. And what this spreadsheet does is it turns it into a blue line. See the blue line there? That's the actual data that we've captured. It's counted how many of those items happened per day of week. And then what it does, the dashed line is its best guess of forecasting what the future is going to be. But as I said earlier on the slides, I also forecasted backwards to see how well that forecast line matched the reality we just saw. And you'll see it gets a pretty good job of it. It gets above the trend line on the weeks that we were above trend line. It gets below the trend line the majority of weeks where we were below the trend line. And then there are a couple of special outliers. You'll see the two red circles. Now, that's where we got it wrong by more than 2 items. And you think, oh my God, the forecast has failed. No, that's not failure. What that is an indicator that historically we've been hit by some special cause. And we need to understand what that is and improve our model, because at the moment this model doesn't cope well with those excursions. And it might be a release, so we get help desk quick tickets sort of saying, oh my God, I don't know how to use those new features, or it might be some other factor. But what you're looking at when you're forecasting is to understand what are those things that are unexpected that you don't understand, so that you can account for them better in the future. So this spreadsheet is called Demand Forecaster. It's pretty simple. You put in numbers or you put in dates that events have happened, and it gives you this sort of prediction into the future. It is a starting point, and if you have people using R or any data scientists on board, they will do better than this. but you're going to have to give them context, and you're going to have to tell them what your special cause events are, no matter what system you use.
Can we take one question that has been sitting in the queue for a while, but is very relevant to take here? So the question is what units or how to quantify the throughput. I think the way you're describing here, these are stories or features completed per unit of time, or could someone use story points? Any thoughts on how to quantify the units of throughput? Does it matter?
So in this spreadsheet, in this type of forecasting, it doesn't matter what unit you use. Whatever unit you enter in, it will forecast the future reliably using that. In this case, this is the number of items. Now, it varies system by system, and I had some slides later we might get to based on whether story points matter. If your size distribution, in other words, if all of a sudden your teams did 5 small things, 2 medium things, and 1 large things per sprint, and they consistently did that mix of sizes of items, then throughput becomes the best forecaster because the size is irrelevant. It's what you're getting through over a period of time. But if all of a sudden you switched over and you started doing 10 large things, 5 mediums, and 1 small thing, now, if you ignored size in that circumstance, in that system, your forecast using throughput would now be wrong. So you've got to really understand whether, in your case, whether the distribution of the size of work is changing over time. And you need to balance that against most delays in delivery of software have nothing to do with the item itself. They have to do with the fact that it just happens that everyone's working from home. I mean, if you would, all of a sudden, it doesn't take many delays of someone working from home to make a 1-point story take the same time as a 13-point story, and some 13-point stories take the same time as a 5-point story. So if you assume that size is the best predictor, you would be wrong in that circumstance. So it matters, and you have to understand your system. And what you're really doing, whatever unit you use, is you're looking for how many of these outliers you get and how well it fits over time. And if all of a sudden it starts to degrade, you need to change your forecasting approach. But industry, start with throughput and prove that it's not going to work before moving to the effort of estimating size. I've seen more errors in estimating of size, assuming that one is going to be 13 times smaller than a 13-point story, and I have throughput being a bad measure.
So your point is use throughput as in stories completed per unit of time rather than story points completed per unit of time.
That is the 90% of the rule, yes.
Yeah, okay, that's good, thank you.
So just finishing up on this section is you got to really know what your system context is that you're forecasting. Are you going to be mainly, is the reliable forecast of the trend, which will be best long term? Is it the trend plus patterns, which are best sort of medium term, out a month or 2 months? Or is it special cause, which means next week or this month? And your mileage varies, and you got to keep a human making these decisions because there isn't a big data or machine learning algorithm which really can handle inventing and understanding special cause and context. They do well on trends and they do well on patterns. They do not do well on special causes, black swan events and so forth. So yeah, were there any other questions on this section in the chat window?
There are a few questions, but let me hold on to those. There's one which I think is easy to answer. The link on the demand forecasting slide seems to be broken. My suspicion is that's because someone is clicking on a webinar link in the display. That should work when we actually get the document available. So other questions, I think, let me hold on till we go further along.
No problem. Yeah, I tested those links so the best of my ability, and if it is broken, we'll fix it and send it out in the email. But I know some firewalls lock Dropbox, and that's normally the problem.
Right.
All right, now we get on to the meaty stuff where people want to forecast duration and dates. So this is the question you get hit with. Yeah, but how long will this feature take? And we can't really get away from that. So let's look at the experts. Let's look at something that you already know about sort of forecasting how long it's going to take to travel between 2 points. We might use, I don't know, Google Maps, Apple Maps, something like that, if you're brave, I suppose. But in this case, we're going to look at more of the best practices that Google have built into this product over the last 10 years. And one factor is notice when they give an answer to how long is it going to take between the 2 points, they give you multiple options. They leave it up to you to choose which route you're going to take, even though one is clearly shorter, one's 21 minutes and one's 32 minutes. One of these has is a much more scenic route. So if it's date night, I'm going to take the scenic route. If I am brave enough to use the public transport during this era, I might take the 33 minutes and just go and catch a bus. And in software, I find it's all too willingly to discuss multiple options as a team, but then just present one answer up the chain. And we've got to stop doing that. We sort of remove the ability to sort of say, this other one is better given this context, and we may not know that context at the team level, but it's known higher up. So always keeping multiple options open is a valuable thing to do. They stick with duration. Notice they don't turn 21 minutes into an exact arrival time. One reason being, and it's obvious, they don't know when we start. But we don't really know when we're going to start a future feature. Likely we're going to start one future feature when the previous one finishes, and if that's late, wouldn't that change the start date of the next one? So Google don't present a time until you leave home, until you say start navigation. And the moment that you do that, they give you an arrival time estimated, and they continuously update it and the time remaining using the latest traffic data. So once you've started, they're continually tracking your progress, and they understand, given the latest data we have now, which we didn't have when you did the original forecast, this is how far and how long it's going to take you to get there. So this is what my call to action for you to doing. If you're currently just giving one forecast, even though you considered multiple approaches and different sort of amounts of delivery of a project or a feature, stop doing that. Start giving multiple options and leave the decision and defer and delay the decision until you have as much information as you can about context on the day you're about to start. If you're currently giving a calendar date when you don't really know what complete means in your feature, you might still be thrashing around what the exact set of ideas are, or you don't even really know what the start date is going to be. You just have it anticipated it's going to start Q2 or Q3 in 2020. Stop doing that. All the analysis you can do in the forecasting I'm talking about can be done using duration. And if the original date starts looking in doubt, don't just sort of try and make people work nights and weekends at the end. Start giving those, giving the original dates, tracking it continuously and reacting earlier when you know that you're wrong. And I think if we do look at making our forecasting and how we communicate uncertainty about what we're going to do more like Google Maps, we would solve a lot of the dysfunction that we have in our software world. So why use this fandangled technology called probabilistic forecasting? Well, often when we give a forecast, we project out an average or a median. And forget this, this is just one of the possible distribution curves that answers in our world can be in. Whenever we actually give a forecast and we project out an average or a trend line, we have a 50% chance of hitting that date or before, and a 50% chance of delivering after that date. And this is called the floor of averages. And I've given a book recommendation there called The Floor of Averages, which documents how many, many forecasting disasters get traced back to using average as a way of projecting what something in the future is going to be and being wrong 50% of the time. So anytime you divide a number of story points remaining by the average velocity, you are actually giving an answer that's only got a 50% chance of being correct. And in our world, with the uncertainty we have, a 50% chance of being correct isn't very good. We often err on the side of being more late than early. So this is called a law of averages. And what we're trying to do with probabilistic forecasting is increase the odds of giving a date or duration that we can actually achieve. And how do we do that? Well, in normal math, we take an amount of work remaining, 25 points, and we divide it by a rate that we do work, 5 stories per week or 5 points per week, whatever you want to use, story points or throughput. And that equals 5 weeks. Now, in probabilistic math, the only difference is that we do that same mathematical function, but on a range of values, 20 to 30 story points remaining, and we get between 1 to 5 stories done per week. And we can equate that out just to a range of being 4 to 30 weeks, being how long. So whenever you hear Monte Carlo forecasting or probabilistic forecasting, all it is saying is just a mathematical technique to solve formulas using ranges of values. And when I'm saying that we're going to do this using data, all I'm saying is rather than saying it's a range 1 to 5, you're going to insert your historical throughput or velocity data into that denominator and get a better forecast based on the actual rate that your teams have historically been delivering. So it's not as complex as it sounds, and some people say it doesn't work. It's like saying the addition operator doesn't work. It is just a process to solve these formulas which have imprecise and unpredictable numbers in them. And how does it work? Well, imagine you did have a team set of throughput samples, and this is the throughput over time. So it's plotted in cumulative form. And then you have a backlog of work that you have to get through, and it's slowly increasing over time. And I'm going to assume that it's not increasing over time. So the quickest way is to just project the green line across and so to say, I'm going to put my head in the sand and say scope isn't going to increase. And I'm going to take the average of the previous 5 sprints and project that line up, and where it hits that green line is the date I'm going to give. Now that's the date that I just said has a 50% chance of occurring. 50% is going to be later than that, 50% chance is going to be less than that. But how less and how late? Well, I could take the worst case scenario and project out, assuming that we took the slowest throughput rate that our team's done, and project a line out to the right-hand side to find out what the likely maximum would be. And then my boss could take the fastest rate and forecast that out and see what the minimum date is. And, best case and worst case, that becomes a very, very wide range. And on one end, the project gets cancelled, one end is so far out that no one would do anything because that's just too far out to rationalize and invest in. So we need something in the middle, but how do we understand how likely an outcome is between these minimum and the maximum ranges? Well, what we do is we start randomly creating possible outcomes over and over and over again. And what that gives us is a pattern, a distribution between the minimum and the maximum of how likely values are to occur in that area. And the more simulations we do, the neater this curve would become. But, we still have these high outliers we have to deal with, and they're likely what you have to consider the special causes and find a way of managing the risk to make sure that they don't occur, because they will really sort of cause a financial impact of delay. And what we can do once we have this set is if we did 1,000 trials, we could say 850 of them finished on or before this date, and that's giving us more certainty in the duration, the date that we're communicating to others. So that's the probabilistic nature of this. All we're doing is giving ourselves a better way to give a future value. So again, I give you a starting point of a spreadsheet which does exactly that. You give it a start date when you know it and be certain that you know it. you give a range of story counts or velocity. It doesn't matter whether you use velocity or throughput here. And you give it, initially you give an estimate of how many stories per week or how many points per sprint you're going to get, low and high guess. And this spreadsheet solves this algorithm for you using the same technique you just saw. It gives you multiple model burn downs in this case, and the orange line is you tracking the actual work remaining, so you can sort of pretty much see that this forecast and the system seem to be working in harmony with each other. Your model is good to give out information, give out duration and dates with some degree of certainty. Hammond.
Yeah, so Troy, let's take one question which I was holding on, which is very relevant here. So the question is there a different consideration for forecasting when we typically, and we meaning the team this is asking the question, they complete more work versus not completing all work? So if the prior data, what I'm understanding is that the prior samples, they end up completing more work. I know it's highly unusual for teams, but if that's their data, is there any different consideration to apply for forecasting?
Yeah, I think once the teams start getting real data, you drop down this box that says estimate and you put data in instead, and then that will recalibrate the forecast using your historical data now. And if you are actually moving faster, the orange line would be appearing below these rat's nests of ideas of these possible outcomes. So although we start off with a range estimate, we start putting in the team's actual data, and if they're going faster than what the forecast said, then the orange line will not appear within the range that we expect. And to put that a different way there, this is what we're doing, the spreadsheet. It's sort of roughly, if you forecast an average, it would forecast out to 50% chance. We're moving across to 85% chance. And the next slide there. Now, if you're moving faster than actually what your forecast predicts, you actually start appearing to deliver earlier and down in these lower probabilities, which is a good thing. And if you're operating slower than the model is saying, you're actually moving further up the likelihood chain, which is sort of accounting for more of those higher end outcomes. So you can often tell whether your team's moving faster or slower and modeling that by seeing which direction your actual data and data is heading towards. Great question. So again, in this case here, if you're just dividing remaining work by average throughput, you're down here at the 50% mark, and you could be out by at least 2 to 3 weeks. So as I was saying, once you get your data, you put your actual data in, and now you're initially given a guideline, and now you're actually seeing the team's predictability, whether they're hitting the work they're saying, go in. So Hammond, did I answer that question?
Yeah, I think that's good.
Yeah. Is that adequate? Okay. So yeah, so the spreadsheet lets you start off with an estimate before you have data, and then move across to historical data once you have it, and it just updates the forecast accordingly as you go. If something massive happens, like you lose half your team, you flick that data drop down back to using an estimate, and then you put in a lower value. And that's what I'm sort of suggesting you're probably going to do at the moment. So that forecasting spreadsheet forecasts a bulk of work. So you might do a project or a very large sort of initiative with. But what I want to encourage you to do is to use this spreadsheet instead, this multiple feature forecast spreadsheet. And what it does is it tells you, you give it a target date, and it gives you a green tick mark or a X check mark based on whether those features have a chance of making it into the next release. And what we're trying to do here is, before a commitment or a promise is made, we want people to have a better understanding of what's not going to make it earlier, because they might choose to trade feature 3 and feature 4, in which case we would change the start order. We would start feature 4 as number 3 and number 3 as number 4. So it's forecasting in this case helps us earlier to decide which features are going to miss, which is a far more productive conversation than trying to get all 5 features in when you have no chance whatsoever. So I find that the better you can tune this using a team's historical data and then collaborate with someone on the order that they want these features delivered, the better the outcomes are. And this is the question we made earlier. That spreadsheet also allows you to put a monthly adjustment in on what the team's throughput will be. And initially it assumes that history is going to play out into the future. But at the moment, it looks like this. Right now in March, we're probably going to have to do a lot of thrashing around and learning about how to work remotely in March. So what this spreadsheet will do is we'll take the historical throughput and halve it for March, a bit more than half for April, a bit more than that for May, and then in June and July it's going to be the new normal, just in time for August in Europe, which means we'll go back to almost nothing happening because everyone's on vacation. September and October we'll probably start getting back to work in the offices and getting back to our normal stride again. So this is a classic case where if you projected the historical data forward, your forecast would be wrong, and not just a little bit, way wrong. So
what
all
you're
of a
saying
sudden,
in this case,
special context matters. Go ahead.
right? So what you're saying, Troy, is you're using judgment calls, your judgment to adjust the multiplier. You're not using any other. I mean, I guess there won't be any other way to do it. So the March you have to just based on your judgment.
You have to have an adult discussion about what it's going to matter. Now, if you already had teams working from home and remote, you're not going to find much impact at all. But if you were a really close team working in an office and all of a sudden you don't know how to work remotely, you're going to be impacted greatly. So even my numbers here are complete guesses. And, all of a sudden teams who are good at working remote, you don't need to adjust their forecast. But the teams who look really stable in person, you do. And this will now be your biggest factor in forecasting, and it's grim, isn't it?
Yeah, makes sense. Thanks.
Okay. So this is what I want you to think about. Often we're told use big data as much as you can, grab as many samples as you can and use it. And especially tools which integrate with your management and tracking software and use every bit of data that you have in the history back to 2012. Well, that data is no longer relevant. And even data that we collected in January and February and the first half of March is almost no longer relevant in forecasting the future. So we're balancing context error about these sort of random events and the team crunching, or that we've blown up a team and we've had to reform, versus the chance that we've got too much variability in the measurement of the numbers that we have. And we're moving between these two polarities constantly. Now, what I do is less than 3 samples, I use an educated guess to guess the range of the rate that we're going to be delivering work in the future. Once I start getting 4 to 7 samples of historical throughput or historical velocity, I start using the data to refine the range of what I saw. And above 7 data points, I always just use the data, but I'm really careful about what data I use. And I would delete data or adjust data based on my understanding of what March, April, and May look like, knowing what we know now. And above 15 samples, I delete the oldest. I only keep the most recent 15 samples that are still relevant, and I delete the rest. I see more forecasting errors by people using data out of context than I do error based on people having too few samples to adequately understand the range of possible values. So delete vigorously is my answer. Don't go keeping old data and expecting it to be good into the future. So that's the key points in this section. Is we're trying to avoid the floor of averages. We're trying to avoid giving a date forecasting out in the future, which just has a coin toss chance of actually delighting and being correct. And we want to move that chance up into what we, the 85th, the 90th, or the 95th percentile, depending on your the cost of being wrong. So if you're being wrong is, if you're heading to the hospital and you're planning when you're going to leave based on the birth of your first child, leave a little earlier. Be a bit more careful. But if it's just you're brave enough to go into work to pick up your favorite coffee cup so you can have it at home, it doesn't really matter as much when you leave home. Remember, in an uncertain world, there's never one answer, and you've got to constantly be looking about for the factors which are going to cause it to change. And you want to start balancing the recency of samples with the number of samples that you have. And I'm going to tell you, it only takes about 7 samples statistically to be 90% certain of the range of values that you're going to be using in these tools. Any more than that, I think you're actually getting too much error based on stale data. So that's the first half of it, and I'm just sort of repeating the links, and again, you'll get this in your email, so I'm going to move on pretty quickly here. I got asked to cover this by Hamid. Is it okay if I cover these, Hamid, or do you want to do questions?
Well, let's do questions. I think in the interest of time, we are now 5 minutes away. We should respect the time box we put ourselves into for the audience.
Okay.
So my suggestion is we can go to the quick intro pages. So let me just tell audience, I think we have a couple of questions in the backlog, good questions I'd like to take on this session. And in the meantime, Troy, if you can move to the quick intro Synerzip pages, I'll quickly introduce Synerzip to the audience while they are typing in additional questions related to...
So are they at the end of the deck?
There are a few pages. If you go forward on this deck, you'll see an intro to Synerzip page after this, I think. Yeah, so you'll have to just...
After this?
Go.
Oh, there we are.
Yeah. So that's the one before this one, yeah. So those of you on this audience, in this group who have not been exposed to Synerzip, this is just a quick intro. We are a software development company. We serve as a co-development partner for our clients and help them accelerate their technology roadmap and leverage our teams in India. And the next page, if we can go to, is our representative list of our clients. These are all software companies. So if you need help, let us know. Now let's go to the next page and take a couple of questions before we completely run out of time. So I'm going to skip commercial for next webinar. This is coming up on April 23rd. But so let's take a couple of questions. So one question that's very relevant, Troy, in the samples you talked about, 7, if you have 15 samples, you pick, 7 or so. How do you balance the rigor of randomly picking samples to allow a statistical process to work versus running the risk that you are cherry picking samples and biasing the statistical process itself?
Great question. Now the math comes out on the, if you Google prediction intervals, you'll sort of see the math on where I get 7 samples and 15 samples. Yes, you are cherry picking, but your cherry picking can be a positive and a negative. If we're cherry picking to try and force a date, then that's wrong. If we're cherry picking to make sure that the samples are in context, that's healthy and productive. Now, what should happen if you cherry pick just to hit a certain date is, remember I said always track the actuals on an ongoing basis. Your actuals will start to fall out of alignment with the forecast, and then you will still be embarrassed and have to fix the samples anyway. So I think the answer is to, I would still prioritize cherry picking for context, and I would absolutely encourage you to track on an ongoing basis actuals versus the forecast to actually confirm that your cherry picking didn't have a negative impact on and set up an unrealistic expectation.
Okay, great. Thank you. So let's take one more question. This question we did cover in the beginning, but seems to be coming up very regularly in the later part also. Using stories versus story points for the purposes of this forecasting. Can you just clarify to the audience, does it make a difference? Just counting stories versus story points.
In 90% of cases, if you actually used story points and throughput, you would get to the exact same result, because it's the distribution of story points and the distribution of sizes that matter. How do you know? The spreadsheets are simple enough. You could do both very simply and very quickly. Now, if they both align, your rule when you use tools in forecasting is you do it as many ways as you possibly can. And if they agree, you use the one that's simplest and requires less data. Now, the throughput forecasting doesn't require any size estimates. So if a team hasn't broken down all the work all the way back into the backlog, you can still do a forecast using throughput that you cannot do using story points. So I'm not going to convince you. If people are asking that question, do a forecast using both. See if they align. If they do, and I will say when they do, consider not using points for a while, just using throughput to make sure that you can better account for those items in the bottom of your backlog that haven't been analyzed by the team and estimated by the team. Make sense?
Excellent. Makes sense. Thank you, Troy. And I know there are a few more questions, and they're all really good questions, but we have to respect the time boundary, and we said we'll get done at 1 p.m. Central, so we need to wrap it up. And I'm so glad you were able to join us, Troy, and thanks everybody who joined us for this wonderful session. And stay safe. See you guys next month and this upcoming webinar on service mesh architectures.